Ladies, if you're in my Algebra 2 class, this is the topic on triangles 6, and we are looking at goal 3, and we're going to learn today how to find the area of an oblique triangle. So let's start with this first question. The area of an oblique triangle can or cannot be found using area equals 1/2 base times height. To answer that question, we need to review the relationship between base and height of a triangle. So if I draw a triangle for you, and I tell you that the base is 5 and the height is 2, and I call them base and I call them height, then you can automatically assume that this angle is a right angle because base and height meet at a 90-degree angle. And that's something that you probably learned in geometry. So if I ask you to find the area of this triangle, because it does have a base and a height, you would say that the area is equivalent to 1/2 times the base of 5 times the height of 2. And so you know that your area is 5 units square, or 5 square units. So we could use 1/2 base times height. For this triangle, we know that base and height meet at a right angle. So try to answer this question. The area of an oblique triangle can or cannot be found using area equals 1/2 base times height. Well, I hope that you said cannot. If you recall from our previous discussion, oblique triangles are triangles that do not contain right angles. So we have two methods with which to find the area of oblique triangles without having to do any fancy geometry tricks and solve for missing parts. So one is when we have an SAS triangle. Let's review what SAS triangle means. So let's draw a triangle here. And an SAS triangle is a triangle in which I know one side, another side, and the angle between those sides. So side, included angle, and side. SAS triangle is a side included angle side triangle. If I knew the yellow highlighted sides and this pink angle, then I would not have an SAS triangle because the two highlighted sides do not include the pink angle, sorry. If I had this green angle, this would not be a side angle side triangle because the yellow highlighted sides do not include the green angle. All right, so now that we've reviewed how to identify a side angle side triangle, let's look at how to calculate its area. So to calculate its area is equal to 1/2 times 2 sides and the sine of the included angle. So the area is equal to 1/2. I should say the product of the two sides times the sine of the included angle. So let's give that some variables. Let's use x, y, and z. So if this is angle x, angle y, and angle z. Using the two highlighted sides and the included angle, I could say that my area is equal to 1/2 times, okay, I know side Y and I know side Z. So 1/2 side Y times side Z times the sine of angle X. So the relationship is 1/2 two sides times the sine of their included angle. And we can use that formula to find the area of an oblique triangle. There's also another formula we can utilize, and that's when we have an SSS triangle. You may recall from our previous discussion that an SSS triangle is one in which we know the measure of all 3 sides. So I'm going to highlight all 3 sides on this triangle. And this is an example of a triangle where we can use this formula called Heron's formula. It's a formula that was derived by a mathematician, and it's important to remember that when you use this formula, you have to know all 3 sides of an oblique triangle. So let's go ahead and give these sides values. We'll call this side A, side B, and side C. Notice we don't know any of the angles. I'm not highlighting any of the angles with arcs, so we know that that's not necessary. So the formula for Heron's triangle is the area is equal to the square root of S. We'll come back in a moment and discuss what S is. Times S minus A times S minus B times S minus C. And I apologize for the sloppiness of this. My remote slate that I'm writing on is not working well at the moment. When we know the 3 sides of an oblique triangle, we can find the area when we multiply S times S minus A times S minus B times S minus C, and then take the square root of that product. How do you find S? S is 1/2 the perimeter of the triangle. Recall that perimeter is the sum of the sides, so you would find the sum of the sides and then find 1/2 of that value. So let's look at examples A and B. We have 2 scenarios here. Example A, find the area of the triangle with side A equal to 6 meters, B equal to 16 meters, and C equal to 18 meters. And remember, we know that A, B, and C are sides because they are lowercase letters. So I want you to draw the triangle and go ahead and label the given information. It helps you to see what you have so you know which formula to use to solve for the area. Okay, so I have a side that is 6 meters in length, a side that is 16 meters in length, and a side that is 18 meters in length. Notice I didn't write down the variables A, B, and C just yet, and I may decide I don't need them at all. When I analyze, I see that I know the measure of all 3 sides of the triangle. I do not know if I have a right angle, so I know that I cannot use 1/2 base times height. So because I have the 3 sides, I will use Heron's formula. With Heron's formula, we need the value of S first. Remember that S is equal to 1/2 the perimeter of the triangle. So the perimeter we would find by adding 6, 16, and 18. So our perimeter is 40, so S is equivalent to 20. So now we are equipped with everything we need to calculate our area. The area is equal to the square root of, remember Heron's formula is the value of S, times S minus A times S minus side B times S minus side C. And again, I apologize for the sloppiness. This is really difficult to write on at the moment. All right, so let's find those values. That's the square root of 20 times 20 minus 6 is 14. 20 minus 16 is 4. 20 minus 18 is 2. So we would open up a calculator page on our calculator and put the square root template in and multiply 20 times 14 times 4 times 2. And remember to either put a decimal after one of your integer values or press Control Enter in order to get a decimal approximation. So it looks like our area is 47.3 meters square. Remember, area is in square units. Example B. Find the area of a triangle having two sides of length 8 meters and 12 meters and an included angle of 135 meters. So go ahead and draw your triangle. Again, I want you to have a visual of what it is that you are calculating. So we have sides length of 8 and 12, so you can, it did not tell you where those should go. You can put 8 and 12 wherever you'd like, but the key is it said an included angle of 135. So included means that side 8 and side 12 create the 135 degree angle. So that is required to go between side length of 8 and side length of 12. So we know this is not a right triangle. One reason, we have an obtuse angle. A second reason, we were never told it was a right triangle, so we cannot assume that. We only know two sides, so unless we want to take the time to solve for the missing side, we cannot use Huron's formula. So but we do know that we do have enough information because we have side angle side to use the area is equal to 1/2 times the product of the two sides times the sine of the included angle. I'm going to do a little more work here so I don't have to type as much on my calculator. I know that 2 will go into itself once and into 12 6, and I know 8 times 6 is 48. So I only need to find 48 sine of 135. So 48 times the sine of 135. Now, my calculator mode is in radians, so I am forced to add the degree symbol here. If you are not sure what your mode is in, you can either stop and check it or place the degree symbol. And I'm going to go back and put a decimal after 48 so that my calculator automatically calculates, and I am getting a value for an area of 33.9 meters square. Remember, I do not use sine to the -1 button because I'm given the angle. We only use the inverse sine key when we're solving for an angle. So the area is equivalent to approximately 33.9 meters square. Thank you, and I hope this helps.